The idea of a fourth dimension has fascinated humans for centuries. It has been the subject of numerous works of fiction and is a common theme in science fiction movies. But is there any evidence to suggest that a fourth dimension exists in reality? In this video, we will explore the concept of the fourth dimension and examine the evidence for its existence. To understand the concept of the fourth dimension, we first need to understand what dimensions are. In mathematics, a dimension is a measure of the number of coordinates needed to specify a point in space. In other words, a point in one dimension requires only one coordinate, such as a point on a number line. A point in two dimensions requires two coordinates, such as a point on a flat surface like a sheet of paper, and a point in three dimensions requires three coordinates, such as a point in space. These three dimensions are commonly referred to as length, width, and height. The idea of a fourth dimension is often associated with time. In this context, the fourth dimension would be time itself. However, this is not the only possible fourth dimension. In fact, there are many different ways to mathematically describe a fourth dimension. One way is to imagine a dimension that is perpendicular to the three dimensions of space. This fourth dimension would be a measure of some property that is orthogonal to the three dimensions of space, such as color or temperature. So, is there any evidence to suggest that a fourth dimension exists? The answer to this question is not straightforward. On the one hand, there is no direct empirical evidence for the existence of a fourth dimension. We cannot see, touch, or measure a fourth dimension in the same way that we can measure the three dimensions of space. However, this does not mean that a fourth dimension does not exist. One of the most compelling arguments for the existence of a fourth dimension comes from the field of theoretical physics. According to some theories, the universe may have more than three dimensions of space. This idea is often referred to as the Brinn world hypothesis. In this hypothesis, our universe is a three-dimensional Brinn, short for membrane, that is embedded in a higher dimensional space. This higher dimensional space could have any number of dimensions, including a fourth dimension. Another possible indication of the existence of a fourth dimension comes from the phenomenon of gravitational waves. Gravitational waves are ripples in the fabric of spacetime that are produced by the motion of massive objects, such as black holes or neutron stars. The existence of gravitational waves was predicted by Albert Einstein's theory of general relativity, and they were first detected in 2015 by the Laser Interferometer Gravitational Wave Observatory, LIGO. Gravitational waves are thought to travel through four dimensions of spacetime. This means that they are not only affected by the three dimensions of space but also by the dimension of time. However, some physicists have suggested that gravitational waves could also be affected by additional dimensions of space. If this is true, it could be an indication of the existence of a fourth dimension. In addition to these theoretical and observational arguments, there are also some mathematical indications of the existence of a fourth dimension. For example, many mathematical models of the universe require more than three dimensions of space in order to be consistent. These models include string theory, which suggests that the universe has 10 dimensions, and M theory, which suggests that the universe has 11 dimensions. In conclusion, the existence of a fourth dimension is still a matter of debate in the scientific community. While there is no direct empirical evidence for a fourth dimension, there are several theoretical, observational, and mathematical indications of its existence. Whether or not a fourth dimension exists in reality is a question that may never be fully resolved.